Hi, welcome to my channel. In the previous video, we discussed about some of the challenges of the machine learning like insufficient quantity of training data, non-representative training data, poor quality data, and irrelevant features of the training data. In this video, we are going to see what is the overfitting the training data. So in order to understanding the training overfitting the training data, we have to understand two things. The first one is bias, and the second one is variance. Variance. What do you mean the bias? Bias is the deviation between the values predicted by the model, and the actual values. Simply it is called as a bias. That means the difference between the actual values versus predicted values is called as a simply bias. And variance is the difference between the predictions when the model fits different data sets. So that means while the model going to give the different values on the different data sets, simply it is called as a variance. So based on these two things, one is bias and variance, we can easily understand what is the overfitting. So for example, here in this figure, there are two types of labels are there. One is a circle and one is a cross mark. So by using our training data, we can easily classify our data into two parts. So that means by using the training data, we are easily classify the two parts. One is a circle and one is a cross mark. So here there is no error between there is no deviation between these two types of things. Okay, simply it is called as low bias. There is no difference between the actual values and the predicted values. So whereas coming to variance, here this model is going to work on the only training data. It may not work on the other training data, other data set. Simply that is called as a variance. So now this is work on the training data. In this case, the bias is very low. In fact, it can be said to be 0 since bias is very 0, since there is no difference between the predicted and the actual values. So this model will give the accurate predictions. So in this model, it exactly classify the two things perfectly. So there is no bias, there is no error in the actual predicted values and the actual values. So however, it will not give this result consistently, because it may predict well on the training data, but when we see the unseen data or test data, it does not contain the same data points as that of the training data. Because of that one, we cannot get the consistent results. Therefore, it will fail to produce the same result consistently, and hence it cannot generalize on the other data set. So when a model performs well on the training data, and does not perform well on the testing data, then the model is said to have high generalization error. Simply it is called as a overfitting. So the model has low bias. That means the actual value, the difference between the actual values and the predicted values is very low, and high variance. That means the model gives the different values at different data sets. This is called as high variance. Is too complex. This is called as a overfitting. So overfitting means the model is good fit on the training data compared to the data. Okay, this is called as a overfitting. So here the model gives the perfect results on the training data, but whenever giving the new data, it may not predict the well. So simply it is called as a overfitting. That is reason why whenever we build a model, it is said to be maintain the bias variance trade-off. So overfitting is also result of the model being too complex. So when the training a model, machine learning model, the goal is to find the balance between capturing the underlying patterns in the data, that is generalization, and not memorizing the training data itself. So overfitting happens when a model becomes too complex. And it starts to learn the noise or random fluctuations in the training data which are not representative of the actual patterns. So imagine we have a data set split into two parts, the training data and test data. Then the model is trained on the training data, and its performance is evaluated on the test data. If the model overfits, it will perform exceptionally well on the training data, and but poorly on the test data because of it has not learned the true patterns. Because of that one, it gives the consistent results. So instead of it has memorized the training examples. So in order to overcome this one, we have to follow different techniques. To prevent the overfitting, several techniques can be employed, like regularization. The first technique is regularization. Introduce the penalties for the large model weights during the training to prevent the model from become too complex. And cross validation. Divide the data into multiple subsets and train the model on the different combinations of these subsets to obtain a more robust evaluation of its performance. And feature selection. Choose only the most relevant features that contribute to the model's performance, and avoiding the noise in the dataset and irrelevant features in the dataset. So you have to find out the best features for the model. So the fourth one is data augmentation. Increase the diversity of training data by applying transformations or introducing the artificial examples, helping the model to generalize the better way. And early stopping. Monitor the model's performance during the training and as well as the testing. Stop the training process when the performance on the validation data starts to degrade. So this is called as a simply early stopping. And ensembling. Combine the predictions of multiple models to reduce the risk of the overfitting and improve the generalization. So in order to reduce the overfitting, this very crucial task, completely eliminating it might lead to underfitting. So where the model is too simple, capture the underlying patterns. Striking the right balance is essential for achieving the good generalization performance on new unseen data. Thank you for watching this video. In the next video, we are going to see one more challenge of the machine learning is underfitting the training data. Thank you.